Welcome to the explainer. Look, if you've ever felt that very specific, very real pain of trying to track down a critical piece of information that's just scattered across a dozen different company apps, you're absolutely going to love what we're unpacking today. We are going to completely deconstruct this highly successful, genuinely impressive internal AI data system built by the engineering team over at Cerebras. And just to put the sheer scale of this into perspective right out of the gate, just 3 months after launching this internal tool, it's already handling over 15,000 internal questions every single day. I mean, that is massive adoption for a newly deployed enterprise system. It's being hit constantly, not just by humans, but by automated workflows and AI agents too. But it makes you wonder, why was this tool so desperately needed in the first place? Well, honestly, it really boils down to these deeply relatable everyday questions. Cerebras is huge. They've got teams spanning data center ops, hardware, chip design, inference, cloud platforms, you name it. And with hundreds of new employees joining every year, their communication channels were literally just choking on the same repetitive questions. Where can I find X? Who's the expert in Y? What exactly is Z? We have all been there, right? The engineering team realized they had to step in. They needed to build a system to connect people and tools directly to useful information, totally friction-free. So here's our roadmap for today. We're going to cover the scattered data problem, meeting data where it lives, taming Slack chats, embedding code bases, intelligent search and re-ranking, and finally wrap up with agents, UIs, and projects. Let's dive in. Okay, section 1, the scattered data problem. Why is it that traditional attempts to organize corporate data almost always hit a brick wall? Well, you know how every few quarters a company typically rolls out what I like to call the failed dream? They try forcing everyone to record everything in one single rigid centralized platform, but it just never works. Information is naturally generated wherever it's most ergonomic for the user to be working. That means pull requests in GitHub, threads in Slack, suggested edits in Google Docs. As the Cerebras engineers rightly pointed out, trying to discuss a complex pull request inside a Google Doc would be a completely terrible experience. So the Cerebras reality is built on a much smarter, simpler premise. Require minimal change to employee behavior, just extract the data directly from where it natively lives. Moving on to section 2, meeting data where it lives. Let's take a look under the hood at the back-end foundation that actually makes this whole seamless extraction possible. So the really crucial takeaway here is how deliberately simple their core architecture is. The basic anatomy of their knowledge base has your standard collection platform, a querying platform, and a security layer for auth. But the actual heart of it all, it's just a single Postgres table. That's it. Every single data source, whether it's a casual Slack thread, a dense Wikidoc, or a hardware netlist, lands in this exact same embeddings table. Each source knows how to connect and fetch its own data, sure, but the resulting row always follows the exact same interface. It acts like a universal anchor, meaning anything sitting in that table becomes instantly queryable through one unified system. All right, section 3, taming Slack conversations. Unstructured data is notoriously difficult to handle, and chat might just be the absolute hardest to tame. We all know Slack is where a company's most up-to-date engineering discussions actually happen, but the Cerebras team quickly realized that standard vector search, it completely falls apart on chat data. The density of information just varies too wildly. Think about it. You have messages that just say, hey, yeah, sure, Mike, sitting right next to incredibly dense kernel explanations. And mathematically speaking, a short, low-value message will frequently and incorrectly beat a long, detailed technical explanation when you're just using standard cosine similarity. On top of that, a single isolated message is often entirely meaningless without the context of the larger thread around it. To get around this, they engineered this incredibly powerful hybrid pipeline. Every Slack thread is retrieved using 4 different techniques simultaneously, and each technique basically covers the blind spots of the others. First up, full text search. This catches exact tokens, so if an engineer is searching for a literal, specific error string, exact lexical matching wins. Second is embedding search, which handles semantic paraphrasing. That means it can connect a question about a hanging restore to an answer about a stalled checkpoint, even if the exact words don't match. Third, they use inverse document frequency to boost rare, obscure tokens, like weird config flags, while filtering out useless filler words like sounds good, thanks. And finally, age decay. If 2 threads answer the exact same question, the one from yesterday is going to beat the one from 6 months ago that's referencing deprecated infrastructure. But they didn't stop there. They noticed that really important insights often get buried way deep inside long threads, and general thread-level LLM summaries were just missing them completely. So they implemented a really clever technique called bursting. A burst is just a run of consecutive messages sent by the same author. What they do is take these bursts, prepend the overall thread topic to give it that much-needed context, and then embed it. It's a brilliant engineering trick, honestly, because it rescues that one vital, completely tangential technical explanation that would have otherwise just vanished into the noise. Section 4. Embedding huge codebases. Handling chat data is one thing, but how on earth do you efficiently search across massive 40-plus gigabyte software repositories? Yeah, so Cerebras has internal repositories larger than 40 gigabytes. Recomputing embeddings for the whole thing every single time a developer pushes code is obviously a non-starter. They solve this using an open-source framework called Cocoa Index. First, the code is intelligently chunked using actual language-specific boundaries. So it tries to split by classes first, falls back to methods if needed, and finally splits into smaller blocks. But here is the real game changer. Cocoa Index tracks synchronization in Postgres. So on every single commit, it only re-embeds the specific code chunks that actually changed. This is huge because it keeps their 40 gigabyte repos perfectly synced in real time, using minimal compute. Next up, Section 5, Intelligent Search and Re-ranking. This is the brain of the system. When an engineer actually types in a question, how does the backend intelligently search and rank the best answers? Well, it all starts with a lightweight, large language model acting as a planner. The planner looks at the user's query and then actively chooses which tools to fan out to. And it's got quite a toolkit. It can use the unified vector search we talked about, do a direct Slack retrieval, pull recent PRs, or even use ripgrep for lightning-fast keyword searches over the code bases. There's even a really cool tool called Who Knows that identifies human experts within the company. The planner dynamically selects the right tools for the job, and then an executor runs them all in parallel. Now, because all these different tools produce completely incompatible lists of results, they have to be merged somehow. To do this, Cerebras uses reciprocal rank fusion, or RRF. Now, don't let the math formula scare you. It's just weight divided by 60 plus the rank. What this smoothing constant is effectively doing is prioritizing consensus. So a document that shows up near the top across 3 different retrieval tools will actually beat a document that ranks absolutely first, but only in one of them. It's basically a consensus builder that ensures a highly robust, diverse set of candidate answers. So here's how that final flow looks. After RRF merges and deduplicates everything, the system takes the top 20 candidates and sends them over to a small re-ranker model. That model scores them from 0 to 10 against the original query, and the top 10 win. But step 3? Step 3 is absolutely my favorite part. They add the surrounding context back to the winning chunks. Let's say a specific wiki section wins, the system automatically pulls in the neighboring sections too. This means the user doesn't just get a lonely, out-of-context snippet. They get the headers, the preconditions, the caveats, the whole picture. Okay, final section. Section 6, Agents, UIs, and Projects. We've talked about the backend, but how do human engineers and AI models actually interface with this incredibly powerful system? The beauty of it is that whether a human is typing a question into a nice web UI or an AI agent, like Claude Code, is accessing the system via the Model Context Protocol, the core pipeline stays exactly the same. The planner LLM chooses the tools, the executor runs them in parallel and normalizes the results. And finally, a synthesis LLM pass takes that entire bundle of evidence and writes out a clean, coherent answer. And yes, complete with accurate citations and caveats. Because the backend retrieval primitives remain simple and LLM-free, it allows these agents to cheaply orchestrate incredibly complex queries. But there is one major pitfall they had to avoid. As their data corpus grew, searching everything everywhere all at once became a total nightmare. I mean, a compiler engineer does not want infrastructure runbooks cluttering up their search results, right? To solve this, they utilize projects. Projects are just lightweight, named bundles of specific data sources. When an engineer onboards, they select their default project, and from then on, it automatically scopes their searches. They only receive high-signal, relevant, domain-specific answers without ever having to manually filter through the noise of the entire company's data. Ultimately, the massive success of the Cerebras knowledge base wasn't just about hastily throwing LLMs at a pile of data. Far from it. It was a rigorous, thoughtful engineering effort designed specifically to respect the user. It works precisely because it meets people where the information already natively lives. It relies on smart, flexible combinations of search techniques rather than just crossing its fingers and hoping a single, rigid, centralized platform will magically solve all their organizational chaos. Which leaves us with this final thought. Think about your own workspace for a second. Are you still trying to chase that failed dream of forcing all your data into one centralized location? Or are you actively building tools that meet your team's data exactly where it already lives? It's a fundamental shift in philosophy, And as we've seen today, the results pretty much speak for themselves. Thank you so much for joining me on this explainer, and as always, keep learning.